Dear students, welcome and thank you for tuning into this video. We are going to continue our discussion about kinematics of particle. In the previous video, I talked about the acceleration, and I would like to elaborate more on acceleration for a special case when we have constant acceleration actually. So how can we find the kinematics quantities for a particle traveling along a straight path if it has a constant acceleration? So the three kinematics equations can be integrated for a special case when acceleration is constant. And what I mean by that is that if you have the position, you derive it to get the velocity, and then you derive the velocity to get the acceleration. And also the other way, if you have the acceleration, you can integrate to get the velocity, and you can integrate the velocity to get the position again. So assuming we have a special case where acceleration is constant, we can obtain very useful equations. And a common example of a constant acceleration is when we have the gravity, an object falling freely to the ground, free fall, so toward the earth. In this case, we have an acceleration which is 9.81. That's the acceleration of the gravity, or that's meters per second square, or you can look at it as 32.2 feet per second square. These equations are actually, we can look at them from a different point of view. For example, if I would like to have the velocity as a function of time, to find the velocity as a function of time, you can integrate dv and ac dt, and you will end up with the final velocity equals the initial velocity plus the acceleration. I'm adding ac, which means that it's a constant acceleration multiplied by t. So that's how we, assuming we have initial velocity v0 at time equals 0. So this is a very useful formula to obtain velocity as a function of time. The second one is actually for obtaining position as a function of time. So you can integrate the velocity and to get the position, and we can use the formula, the integration, to find the equation, which is s equals s0, which is the initial position, plus v0t, which is the initial velocity multiplied by time, plus half ac t square, and ac is the acceleration, right? So this is another formula that we can use, assuming we have constant acceleration, to find the position as a function of time. Another formula, actually, we obtain it, actually, which is obtaining the velocity as a function of position. And having this, actually, this is a special case, and it's an important differential relation that involves displacement, velocity, and acceleration along a straight line in which we are eliminating time, differential dt. Between the equations. So we end up with if dt equals ds over v, and it's also equal dv over a, and so since dt is the same, you will end up with a ds equals v dv, and if you did the integration, you will end up with the formula v square equals v final square equals v initial square plus tac multiplied by the difference in position. And that's a very important formula, as also we are using it a lot in kinematics, assuming that we have a constant acceleration. That's very important, and we're going to solve a couple of problems that will show how we can implement and utilize all these equations to find kinematics quantities for a particle moving in a straight line with a constant acceleration. Thank you for watching this video. Until the next video. Bye.